Welcome to another problem session, and this is the last section of 2023 JEE paper 2 and section 4. This section has questions like two questions in the same setup. Okay, so let's take a look at it. So you have a setup, these are called paragraph questions. So like we'll have a paragraph 1 and there will be question below here, and the next question is for same paragraph, but there's a separate question, and there are two of them, and I will do them in two separate videos. Okay, so there will be, each video will answer two related questions. So we're going to do this one in this video. Okay, so this question is it's a question on Doppler effect for sound. Okay, so there are these two sources of sound, S1 and S2, and in question 14, the first question on this paragraph is although this setup has two sources, only S2 is emitting. Now S2 is going in circle like this, and you could ask question at arbitrary point, but they have picked up a point Q and R, and P is a point where there will be a detector. Okay, so let's see what we know about Doppler effect. So Doppler effect, you will have there are three things. You have a medium, of sound, so it's like this is some air or something like that. So this is a reference frame. Say this is reference frame O, and then there is a detector of sound. So this is the detector, and then there is emitter of sound, emitter of the sound, and so each one can be moving in whatever direction, right? So if so there are three frames. So let's see the velocity of this, the speed of this with respect to this. This can be moving in that direction, maybe say VD, and this guy is maybe moving this way, maybe VE vector. So what matters is this line of sight between them and the relative motion. So this direction, we're going to call it parallel direction. So there will be VD parallel and VE parallel. Okay, so if this thing is emitting a sound of frequency FE, and if the sound gets detected, the same sound gets detected, let's call FD, then FD is related to 1 plus or minus VD parallel, 1 plus or minus V, V, maybe sound is a speed of the sound in the medium is V, and that's the V over there. So V plus minus V emitter parallel components. These are parallel components, and FE. So this is the relationship. You'll if they are moving towards each other, the way you pick plus or minus sum, if moving towards each other in the parallel direction, then detected will be greater than FE, so that's how you're going to pick plus or minus sign. If away, then FD will be less than FE. So this is the Doppler effect. So suppose over here in our problem here, the detector will be fixed. So if the detector is fixed, then if emitter is moving away, then this will detect a lower frequency. If this is going towards it, then it will detect a higher frequency. And the only thing we have to do is do the parallel direction. All right, so let's it's really a very simple problem. This parallel direction you have to work out. So the question here is if I look at this is fixed, so V sub D is 0 with respect to this frame, outside frame, medium frame, and over here it's moving this way. V sub E with respect to this is moving that way, V sub E. So if you look at it's actually, if I project, this is a parallel line, so it's moving away from the detector, which is point P, and this is point Q in the diagram. So this is emitter and this is detector. So so frequency that will be detected will be V, because this guy is 0, so V over V, and frequency will be smaller, so minus, and I need to get a parallel component of this. So this angle here is 45 degrees, so this angle is 45 degrees. So if I look at a component of this along this direction, along the direction of line of sight from P, from the detector, this will be just if this right arm is 45 degrees. So if this was theta, then it will be just VE cosine theta. So VE cosine theta, which is theta is 45 degrees. What's given is the speed VE is given as 4 square root 2, and cosine 45 degrees is 1 over square root 2. So these guys will cancel out, right? And emitter. So let's write down V is given in the problem 324, and this is given as 324 minus this times this is just 4 of 4 square root of 2 by 1 over square root 2, and this whole thing is multiplying 656 hertz. That's over there, 656 hertz. Okay, so this algebra is probably not that so this 320, and the frequency will have to go down because of the way, so this should be plus and 328 times 656, and this just factor of 2, so we got a 648 hertz. So that's the answer, and we're supposed to give the answer in has to be given to each answer is a numerical value, and so round off to 2 decimal places. So it will be 6.48 times 10 to the 2 hertz. So 2 significant decimal places. If you write down the scientific, this will be the scientific notation. Okay, so that's one source problem. Then we have a two source problem now. So when we have a two source problem, and sound is coming from here and coming from when S2 is way over here. So if we look at what we got here, so if I redraw it over here, S2 is over here going this way, and S1 is over here going this way, according to this description of the problem. If you read the problem, okay, and then consider both sources meeting. S2 is at R and S1 approaches the detector with a speed 4 meter. So this one is V1 is 4 meter per second, but going this way, and this is 4 square 2 meter per second, but going this way, and the detector is in this line. So if you look at this is V2 is, if you look at a V2 parallel, V2 parallel is 0 actually. V1 parallel is actually coming down, so it's a negative, looking in this direction, negative. So it should increase the frequency. So I'm just going to do absolute value and positive negative. I'll just use the positive negative from concept of increasing the frequency or decreasing the frequency. So this should increase the frequency, and this will be just straight for writing as absolute value meter per second. So this will create a sound F2 at the detector will be V over V, and of course this detector is 0, V sub D is 0, so V plus minus 0 plus minus parallel is 0, V2 parallel is 0, times F2, which is 1 times 656 hertz. So we have 650 hertz. This will create a sound F at the detector. It's going to detect at the sound V plus minus 0, and V is going to minus, because I want the frequency to, this frequency to be higher than this frequency. So minus 4, and so this will be equal to 324 over 324 minus 4 and times 656 hertz. So let's see, so this is 324 over 320 times 656 hertz. So beat frequency F beat is equal to the difference between F1 detected and F2 detected. So this difference between the two, an absolute value. This you have to remember. So this is the thing you have to remember. There's a derivation you can see in all textbooks in this subject. So this just gives me this will be bigger. So 656 times 324 over 320 minus 1, and that's just 656 times 300, actually 4 over 320. So we would need a calculator, and let me just do a calculator. Okay, so I just did a quick calculator, and that's 8.2 hertz. So that's the answer, and this already 2-digit. All right, so that was a really cute problem in Doppler effect. You should definitely learn how to use this, and and the beat and together with f beat is f1 minus f2. So these are two formulas that we made use of. Okay, so I'm going to do the second problem or second paragraph, two problems there in the next video. See you there. Bye.